Hello and welcome to Amazing Space, your guide to the cosmos, where we bring you the latest news and discoveries about what's going on in astronomy field. Today, we're discussing a groundbreaking idea in space propulsion that could send a probe to Alpha Centauri. This paper was first reported on January 6, 2025, and it's already creating waves in the space exploration community. In today's update, we'll dive into a fascinating development in space exploration that you won't want to miss. Researchers have proposed a new way to send a probe to our closest neighboring star system, Alpha Centauri. The method involves using a relativistic electron beam, essentially a high-speed stream of electrons, to propel the spacecraft across interstellar distances. Now let's break this down. The idea is called the Sunbeam Project. Here's how it works. A satellite would be positioned near the sun. This satellite would generate a powerful electron beam and direct it toward a spacecraft. The beam would push the spacecraft forward, much like wind pushes a sailboat. So, why use an electron beam? Well, traditional methods for interstellar travel, like rockets, are too slow and inefficient. Even the fastest spacecraft we've built would take tens of thousands of years to reach Alpha Centauri. The Sunbeam Project aims to drastically cut down that time. With this method, scientists believe they could send a probe weighing up to 1,000 kilograms, that's about the weight of a small car, to Alpha Centauri within a human lifetime. That's a significant improvement over current technology. But why electrons? Why not use light or lasers as some other propulsion concepts suggest? The key advantage of using electrons is that they can provide continuous acceleration over long distances. Unlike light, which spreads out and weakens as it travels, a well-controlled electron beam can maintain its intensity over vast distances. This means the spacecraft could keep accelerating for much longer, reaching much higher speeds. And of course, there are challenges. One big challenge is maintaining the coherence of the electron beam over such vast distances. In simpler terms, the beam needs to stay focused and directed at the spacecraft. Any deviation, and the probe could lose its propulsion. Another issue is managing the charge on the spacecraft. As the electron beam hits the probe, it would build up an electric charge. Too much charge, and it could interfere with the spacecraft's electronics. Scientists would need to find a way to neutralize this charge to ensure the probe functions properly. Despite these challenges, the concept has generated a lot of excitement. It opens up new possibilities for interstellar exploration, a dream that humanity has had for decades. To put things in perspective, Alpha Centauri is about 4.37 light-years away from us. That's roughly 25 trillion miles. Even with the fastest conventional spacecraft, it would take over 70,000 years to get there. The Sunbeam Project aims to cut this travel time down to just a few decades. Let's talk about the potential missions. A probe sent to Alpha Centauri could carry instruments to study the star system's planets, if any exist, and look for signs of life. It could also gather data on the interstellar medium, the space between stars, which remains largely unexplored. But beyond the scientific benefits, this project represents something bigger. A step toward making humanity an interstellar species. For the first time, we'd be sending a human-made object to another star system. Now, let's address the question, why Alpha Centauri? Alpha Centauri is our nearest star system. It consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Proxima Centauri, the smallest and faintest of the 3, is the closest to us, and has at least one known planet in its habitable zone. This makes it an ideal target for interstellar exploration. But we're still in the early stages. The Sunbeam Project is a concept. There's a long way to go before it becomes a reality. Researchers need to conduct more studies to figure out the feasibility of maintaining a focused electron beam over such vast distances. They also need to develop technology to manage the probe's electric charge. If successful, though, it could revolutionize space travel. Imagine launching a probe today and having it send back data from another star system within your lifetime. That's the kind of future the Sunbeam Project envisions. And it's not just about Alpha Centauri. Once we have the technology to send probes to one star system, we could send them to others. It could open up the galaxy for exploration. So, what's next? The researchers behind the Sunbeam Project are continuing their work. They're exploring ways to refine the electron beam technology and address the challenges we've discussed. They're also looking at how to build a spacecraft capable of withstanding the journey. A journey that would take decades and expose the probe to harsh interstellar conditions. In the broader context of space exploration, this project is part of a growing interest in interstellar travel. Other initiatives, like Breakthrough Starshot, are also exploring ways to send tiny probes to Alpha Centauri using laser propulsion. But the Sunbeam Project stands out for its unique approach. By using electrons instead of light, it offers a new way to think about space propulsion. In conclusion, the idea of reaching another star system within a human lifetime is no longer science fiction. It's a real possibility thanks to projects like Sunbeam. We may be closer than ever to taking the first steps toward becoming an interstellar species. That's all for today's update from Amazing Space. Thank you for tuning in, and remember to subscribe for more updates from the universe.